For thousands of years, sailing was simple. The wind pushed the boat from behind, meaning the vessel could never travel faster than the wind itself. But today, modern racing yachts have completely shattered the speed limit. High-tech racing yachts like the S-75 or sail like the S-50 do not sail through the water. Instead, they fly above it on carbon fiber hydrofoils, reaching speeds over 50 knots in light breezes of just 12 knots. How did they achieve this incredible feat? The secret lies in a physics feedback loop. First, we must understand the difference between true wind and headwind. True wind is the natural breeze blowing across the water. Headwind, on the other hand, is the wind created by the boat's own forward motion. If you sail forward at 20 knots, the crew experiences a 20-knot headwind blowing straight over the bow. Apparent wind is the actual wind felt by the boat and its sails. It is the vector combination of the true wind and the headwind. This apparent wind is the driving force that powers the sails. Imagine driving a convertible at 50 miles per hour on a windless day. You feel a 50 mile per hour headwind. If a 10 mile per hour side wind starts blowing, the wind you feel inside the car shifts diagonally. This is apparent wind. As the boat accelerates, the headwind increases. This shifts the apparent wind further forward and increases its speed. By trimming the sails to match this new wind, the boat generates more lift, accelerating even faster. Modern racing yachts do not use traditional sails that catch the wind from behind. Instead, they sail at an angle to the wind, using rigid sails that act as vertical airplane wings to generate aerodynamic lift. As wind flows past the vertical wing sail, it splits. Air traveling over the curved leeward side speeds up, creating a low-pressure zone. The slower air on the windward side creates high pressure, generating lift. According to Newton's third law, the sail deflects incoming air windward, creating an equal and opposite reaction force pushing the sail leeward. This total force is split into driving force and heeling force. The driving force pulls the boat forward along its track. The heeling force, however, pushes the boat sideways, attempting to tip it over. To sail forward, this sideways drift must be blocked. To counteract the sideways wing force, the underwater foil acts as a second wing in the water, generating hydrodynamic lift in the opposite direction. The combination of these two forces squeezes the yacht forward. It is like squeezing a wet bar of soap between your fingers. The sideways forces compress the soap, but because of its wet shape, it shoots forward. The sail and the foil act as the compressing fingers. Traditional boats are limited by the physical resistance of water. Displacement hulls plow through the water, creating high drag. Hydrofoils solve this by lifting the entire hull out of the water. Because water is roughly 800 times denser than air, a small underwater foil can generate the same amount of lift as a massive sail in the air, easily supporting the weight of a multi-ton yacht. Once a hydrofoiling yacht reaches its takeoff speed, typically between 12 and 18 knots, the foils generate enough vertical lift to raise the hull above the water, cutting total drag by over 90%. Think of a heavy barge plowing waves versus a water skier skimming the surface. The skier pops up, reducing drag. Hydrofoils act like high-tech water skis that lift a 7-ton yacht completely out of the water. Modern racing yachts use T-foils or L-foils. The horizontal wing of the foil generates the vertical lift to fly the boat, while the vertical strut acts as a keel, providing lateral resistance to prevent sideways drift. At extreme speeds above 50 knots, pressure on the upper foil surface drops so low that water boils at ambient temperature, forming vapor bubbles. When these bubbles collapse, they cause sudden loss of lift and foil stall. A sailboat acts as a physical wedge compressed between two moving mediums, air and water. Because the boat is restricted by its foils to travel along a track in the water, it slides forward like a squeezed seed. If you squeeze a wet watermelon seed between your fingers, it shoots forward. The weight acts as one finger, the water as the other, and the yacht is the seed being launched forward far faster than either finger is moving. A boat sailing directly downwind can never go faster than the wind because once it reaches wind speed, apparent wind drops to zero. By sailing at an angle, the boat preserves high apparent wind speed, exceeding true wind speed. Modern hydrofoiling yachts regularly achieve speeds 3 to 4 times faster than the true wind. They can sail at 45 knots in a light 11-knot breeze because their forward motion generates massive apparent wind. The world speed record holder, Vesta Sailraka 2, reached an incredible 65.45 knots in 25 knots of wind. It utilized a specialized rigid wing sail and a custom-designed stabilizing hydrofoil. The economic cost of these carbon fiber yachts is staggering. Constructing a single S75 raising hull ranges between $000 and $000, driven by aerospace-grade materials and custom composite construction. A single set of custom-engineered carbon fiber hydrofoils, which must withstand structural loads of over 20 metric tons, costs between $500 and $000 in research, development, and manufacturing. A competitive America's Cup campaign requires a total budget exceeding $100 to cover engineering design teams, advanced weather simulators, logistical operations, base camps, and support vessels. To prevent runaway spending, the 38th America's Cup has introduced a team cost cap of approximately $7,000, helping control extreme engineering expenditures and keeping the competition fair. Elite teams spend between $5,000 and $0 on advanced computational fluid dynamics software and high-performance computing clusters to optimize foil shapes before physical construction begins. Modern sailing is no longer just about catching the wind. It is a high-stakes, aerodynamic flight on water. By combining apparent wing loops, wing sails, and hydrofoils, these yachts fly faster than the wind itself. Understanding the laws of physics helps us unlock incredible speed and design the future of travel. Thank you for watching this episode of Layman's Field. We hope to keep bringing knowledge for everyone.